Okay, in this chapter, we will look at chapter 9, and this one talks about what are some ways that we can solve problems. What you're looking at is it's a model of problem solving in which the problem happens in a context where the problem solver needs to recognize a situation, right? That requires some action. And based on the action on a series of steps, that you will make sense of the situation and deciding what action to take based on guiding principle and then implement that action. It seems like a lot, but basically what we're trying to look here is like anytime, if you look at enterprise intent is, let me check. Okay, enterprise intent is to be top-end service quality market leader. Now, if that is the main problem that you're trying to solve, you cannot just go out and start implementing. You need to look at what is the situation, right? How can we make sense? This is very crucial. Anytime you look at a problem, let's say you're looking for some kind of food. Now, you're hungry, and depending on the place and the time, you would decide what to eat, right? If you're out somewhere middle of nowhere, you would not expect a certain type of food. You would just go for what's available. And also, when you make decision, it takes quite a few steps, and that's what we're going to learn here. Now, just to give you a little heads up, anytime you try to solve a problem, there's some level of persistence, right? Perseverance required. You need to have endurance, right? So I have a scale for you to test, and I'll put that in the canvas so you can prepare yourself, right? And anytime you think of a problem solving, very important part is you try to look at the preparation or familiarization stage, where you try to include the time spent in understanding the nature of the problem. And you also know the desired goal and what are some givens. Next, you will try to think of, during this production stage, you try to think, produce solution paths that define the problem space. And on the third stage, you try to evaluate, right? As a problem solver, you evaluate solutions path to select the best one. And finally, you have incubation period. Now, if you think of incubation, there's a popular story about Archimedes, right? And he was asked to identify, or the king gave him an order to weigh how much the king's crown in terms of the gold. And now he has a task that he cannot destroy the crown, right? It's a metal, and you cannot destroy it. You need to identify its volume. Now, it's not just the weight itself, and although the other density, all of that. Now, he was given this task, and he could not destroy before finding out the answer. So the story goes like he went to take a bath in a tub, and the tub was filled with water, and he got naked, got in the tub. As he got in the tub, there's a certain amount of water overspilled from the tub, and that gave him like a eureka moment, right? You heard of that, eureka? That's Archimedes' expression for like, I found it, or I discovered it. And that's when he walked out of the tub and run around the city naked, screaming, eureka, eureka. And it's just a story to tell you the incubation period. I have a link in the video, shows that when you try to solve a problem, you go through all the steps, right? All the steps, identifying the problem, thinking of different solutions, and evaluating your solutions. But the important part is you need to take a break. That's what it means, right? Incubation means you need to take a break as you try to solve problems. And it could happen in anything. You might be thinking about a project, applying for a job, moving out. All the problems that you're trying to solve may require multiple steps, but definitely you need that break And that's what it is, like the period when you try to not actively work on the problem. And sometimes that happens in, like, in the timeout period, you come up with the best solution. So that's what incubation is. And this is allowing you to test whether you are persistent in a problem. So you will see, I'll put a survey on Canvas, so you can do it here or you can do it on Canvas. So you use those acronyms to test yourself on these skills. When I used to teach online, I mean in person, I used to do this in class and tell, who is the grittiest person in our class. So this helps you to identify whether you have a strong grit and you think of a problem or not. And once you rate yourself on each item, and you can compare your score in this scale. Now, if you have the maximum score of this scale, which is like if you have close to 5, that means you are very gritty. And one thing you should know about grit is it has nothing to do with your IQ. If you're interested, click the link and you can watch a brief video by Angelica Duckworth. She does a lot of research on grit, and she found that students, those who are successful in grade schools, have little to do with their IQ, but more to do with their perseverance, right? That's very important. So if you've done that, then we can look at some approach to solve a problem, right? Before we solve a problem, the problem, sometimes it's easy, right? For example, if I ask you to, what is the area of this parallelogram? I don't know if I'm not sure if I'm saying that right. Parallelogram. Now you can simply multiply 3 by 5 to get the area of that parallelogram, which is equal to 15, and that would be in inch, so it would be square. So the parallelogram, or the answer for this question, why the problem is well defined. Now, if I ask you to write a good poem or sketch some kind of art, that would be a little challenging because the problem is not well defined. It's ill-defined. So when you think of ill-defined questions or problems, you are now thinking about, well, what do you mean by a good poem or beautiful poem? Am I writing about the nature, abstract? Am I writing about, not sure, life, tragedy, romance? So it's hard. So there's a lot of vague and incompleteness in that question. So the bottom line is, we want to give the problem, evaluate the problem, and try to think, are there one clear answer or there are so many answers to the question? So that is where it comes to defining the problem, right? Now, first part, when you try to think of solving problems, make sure you know whether the problem is defined well or not. I should get serious about my life now versus restate the goal in multiple ways to generate solutions. Now, this is, again, a little vague. Like, I don't know what you mean by that. Do I need to up my game with the school, work, relationship, or go to the temple, become a monk for some time? Not sure, right? Now, if you think like become responsible, okay, that's something we can jot it down into certain areas of our life, right? And that can lead to, if it is career-wise, you can find a solid job, maybe move out of parents' house, complete education, apply for internship or scholarship. So depending on the problem, solution could vary. So the bottom line is, make sure your problem is defined clearly so you can generate some solutions. And that's what we're going to do here, problem solving strategies. And for simple task, if I ask you, do the math, right? 3 plus 5, you can easily tell. You don't even need a piece of paper. You can tell 8. Okay, 5 times 5, you can simply tell it's 25. 8 times 8, if you are good at math, you can very quickly answer those questions. Why? Because they don't require multiple steps. But what if your problem has so many layers? Can you just use your mental calculation to come up with the answer? Now we'll see some of the strategies. And one thing we should go back to your early knowledge is about memory. If you remember, your short-term memory holds certain amount of information. In general, the rule is it can hold up to 7 units, not 7 numbers or digits or letters. It's a 7 unit. It's like if you chunk certain information, it can hold up to 7 more or less steps or units of information. That's again in general, not like a solid science, but in general, if I give you a task of number, if you remember the games we played, you can only remember so many. After 7, it becomes a little overwhelmed because your brain is now trying to hold too much information in short-term memory. Same thing applies to when you think of solving problem. When you try to solve problem that has more than just simple addition or multiplication, you need a little more strategies. And that's what we're going to have fun in this next couple slides, right? Here's one problem. Now you can pause the video and you can try to think of solving this. Irvin has begun a jogging program. He jogs 2 miles north. Now if you think of just imagining the direction, I mean, I'm not really good at directions, but if you are, still it will be hard. So the best thing to do is, like here it says, representation is draw a graph or a diagram. Now you can draw a chart like that, right? And you know north is here, south is here, and you try to put your letters as you go. So 2 miles north, then turn right and jog 3 miles. Now if you, again, I needed another thing to add here. Okay, you draw a graph. What you can do is you can also use some kind of a legend like this, whatever length is equal to 1 inch, and 1 inch is equal to 1 mile. So if you do that, if you move, so if you look at this, jogs 2 mile north, so 1, 2, that's 2 mile, and then head left, right? He head left a mile, so that's another mile. Then turn and jog 2 miles to the right. Now that means 1, 2. So it's coming back. And so if you keep doing this, and if you keep drawing your chart, it will give you direction where he was heading, and you will find where he ended. Now I want you to try this. I've done this several times. I want you to try and see where he headed. But the bottom line is not finding out where Irvin went, but using graph and diagram. Now, this works when you're trying to do a concept flow. I was just doing my proposal for timeline. You think of like, okay, I'm now in April or May, and I want to think of submitting IRB, data collection, data analysis. Now I cannot do like that because before I get data collection, I need to do IRB. After IRB is done, then I'll do data collection. In the meantime, I will do some lit review. And once I have data, I'm gonna, so you see the concept, right? You use different approach to look at the problem rather than just thinking of like this, 2.2, 2 plus 2 is 4 or all that, right? So one approach is representation. Here's another one. And there's another question. You can pause and try this. I missed teaching this class online because we used to solve this problem in class. It's more fun, but you can do it. You can pause and think of like how do you figure out which dog eats crunch blend good dog food. So to identify that, you have quite a bit of prompts, and you cannot just look at them and try to hold all the information in your short-term memory. You might just plug them information in a table and you will see. I'll just quickly show you the solution if this matches yours. So just do this first and then check the answers. And here is another approach called trial and error. We do that all the time. When you're learning a new skill, you try to think of how can I solve this problem, right? You do and you fail, you retry, you fail, so on. So that's trial and error. Now solve the following anagrams. Use a strategy that recommended for problem with this solution path, right? I have to come up with a sensible word. What would be this? Now if you use this, you can see, you can think of car, and here, what do you be, the NUT? So do similar tasks. And here's another approach. Oh, it's actually I got the right letters, right words. Okay, here's another one. Think of possible words that you can generate using these 5 letters. Again, there will be trial and error. The point again is not this particular task, but you have to think of how can I solve this problem by trying, making mistakes, and revisiting. And here's another fun, oh, there's the answers. If you try, oh, this is again trial and error. How can you draw this shape with one continuous line? It doesn't mean like a straight line, of course you go around, without lifting your pencil off the page and without crossing or retracing. So you cannot do like this, right? That is not okay. You cannot do this, so you cannot cross over. So before you look at the answer, try this. You can just use a pencil, paper, and try if you can do it. Again, the point is you are learning to solve problem with trial and error. And here's the solution. So if you think of how to get there, so 1, 2, 3, and it shows you can easily draw this without overlapping or lifting your pen. And here's another one, your mental set. It requires, you take a break, because I have done this before using 6 short sticks or pencils, arrange them to form 4 equilateral triangles. So equilateral means they have the same distance or same length. So if you're using 6 pencils, you cannot be overlapping one pencil to another. I played this game in my classes, but it will allow you to use this technique. You think your different perspective to solve the problem, and I want you to try. So get 6 pencils. You have 6 pencils, and try to see if you can show 4 equilateral. That means each side of your triangle should have the same distance. There is no dividing the pencil over it. When I do class, in my class, students normally show like this. Now here it's not equilateral because, okay, these are good, but these are not good. You see, they are not equilateral because you divided a pencil to put in 2 sides. Now if you choose to do 4 pencils this way and put 4 pencils that way, you need 8. You can't do it with 6. That's why you need a little bit of imagination, and you might need to take a break. So if you tried, you might see something like this. Again, if you tried, you would get a chance. Now what happened here is you use the mental set, which means you took a break. Instead of thinking from length and width perspective, you try to use the depth, right? That's what it is. So there's a little depth. It's a pyramid shape that allows you to build 4 equilateral triangles with 6 pencils. Now if you think of equilateral, these are same in distance, all of them, right? Okay. And here, complete the following letter series. It's a functional fixedness. Okay, this letter series is made up of the letters of few things. Now if you continue to think, okay, how do I go beyond O, T, T, F, F, S, S? Well, if you are thinking beyond what you're given, you might have like a little insight, like what is it? What is this representing, right? Instead of being fixed in a certain problem, you try to look at this like, if you think of what's the sequence here is that 1, 2, 3, 4, 5, 6, 7. So the next letter would be E, N, T, and so on. Why? That's 8, 9, 10. So you look at the problem from multiple angle, right? That helps to solve the problem. Yeah. And the other strategies you can think of is generalization. It's a strategy in which the problem is considered as an example of a larger class of problems. All parents try to make life difficult for children. I mean, that is not the best way to solve the problem, but sometimes it works because you're trying to generalize the solution, thinking from the broader perspective. This happens in research, right? You try to generalize your finding. Like, let's say I'm collecting data from 400 CSU students. And I cannot study all, I don't know, there's about 18,000 students in our school or a little more. I cannot study all of them. Now, based on this data, I try to make an sort of an implication about our school. And specialization involves considering the problem as a specific case drawn from a large set of problem. My parents have rules for everything. That's an example, but from research point of view, I can see that instead of doing a survey, if I did interview, I will get a very specific solution to, for example, foster students, those who have gone through foster parenting, or parent students, those who are raising children, or single mother parent students, single parent students. So all that would be specialization. You come up with a solution to a particular case in the larger group, right? Now this is another example for those. And here's another strategy: means end analysis. That means you break the problem into smaller problems and solve the sub problems and to meet that goal. Now, if you have played this Tower of Hanoi, you can actually play with the link. You cannot just move the whole 3 disc to this one. You have to do in minor steps. So if I were to play, I'll move 1 here first, then I move the 2 here first, then I move 1 back top here, then I move 3 here. I don't know if you're following. I can move 1 back here and 2 back here and put 1 back here. So you slowly move the disc, because the Tower of Hanoi has a rule: you cannot have a smaller disc under the larger disc. So it's a fun activity you try to do, and that's how you try to identify what's the end result that you need. How can you break that problem into smaller pieces? I hope this is helping. So I'm trying to give you some solutions, right? Now here's another problem for you to think. I'm going to skip the answer for this one, right? If in a lake, if there is a patch of lily pads, every day the patch doubles in size. If it takes 48 days for the patch to cover the entire lake, how long would it take for the patch to cover half of the lake? Now, if you quickly think, oh, it took 48 days to fill it, it should take only 24 days. If you thought that, that is incorrect. So I'm not going to show you the answer. I want you to try this one, okay? Let's see. And here, I had a couple more solution problems, but look at this one. Now, write down any information you think is important, okay? Suppose you're driving a bus. Suppose you're a bus driver. On the first stop, you picked up 6 men and 2 women. At the second stop, 2 men left, and 1 woman boarded the bus. At the third stop, 1 man left. Excuse me. 2 women boarded. At the fourth stop, 3 men left and 3 women boarded. Okay? If you're paying attention, let's see if you can answer this question. Oh, there's some animation. What is the bus driver's age? Now, if you're paying attention without going back, see if you can tell that. That's another part which I try to emphasize. You need to think of solving the problem. There is some level of mindfulness required, right? I need to delete that slide. Okay, so I have some practice questions that I might put it in a Canvas quiz, so you can try them, so that will prepare you for your exam. And I'll post another video on creativity sometime sooner. Okay, thank you.